Hi everyone, welcome back. You're watching Math with Anila. In the previous class, we have seen about the trigonometrical ratios. Today, let's find some of the values of the trigonometrical ratios when the measurement of the sides of the right angle triangles are given. Look at this question. We need to find sin A, cos A, cot A, sec C, cosec C and tan C. In this given triangle ABC, the measures of AB as well as BC is given and the third side AC is missing. So first we need to find the length of AC. This can be found by using Pythagoras theorem. So if this is a right angle triangle, the hypotenuse square is equal to base square plus altitude square. And as we have studied earlier, AC is the hypotenuse since this is the side which is opposite to 90 degree. Now AB is the altitude and BC is the base. Find the value of the hypotenuse. The altitude is 3, so this will be 3 square plus the base is 4. 4 square is equal to hypotenuse square. 3 square is 9 plus 4 square is 16 is equal to hypotenuse square. And 9 plus 16 is 25 and that is same as the hypotenuse square. Therefore, hypotenuse is equal to square root of 25. That gives you the value plus or minus 5. But we consider this as plus 5 since the length of a side cannot be negative. Therefore, we got the value of the hypotenuse as 5. The value is 5 here. Now let's find the trigonometrical ratios. The first one is sin A. Here we are considering angle A as the angle of reference. So sin A is equal to, since we are considering angle A as the angle of reference, BC is the opposite side and AB is the adjacent side. Adjacent side. Now let's write the ratio to find sin A, that is opposite side by hypotenuse. So opposite side by hypotenuse and that is equal to 4 by 5. The second one is cos A. Cos A is equal to adjacent side by hypotenuse. Adjacent side by hypotenuse and that is same as 3 by 5. The next is cot A. Cot A is adjacent side by opposite side. So the adjacent side is 3 and the opposite side is 4. So 3 by 4 is the value. The next one is sec C. Sec C. According to the ratio, sec is hypotenuse by adjacent side. But here we cannot consider this adjacent side since the angle of reference is C here. So we need to change the opposite side as well as the adjacent side. Now we have to consider angle C as the angle of reference. When we are considering C as the angle of reference, AB will become the opposite side. AB is the opposite side and BC is the adjacent side. Now let's write the ratio. Sec C is equal to hypotenuse by adjacent side. Hypotenuse is 5. I have told you that remains same always since it is the longest side and it is opposite to 90 degree. And hypotenuse by adjacent side. Here the adjacent side is 4. So that is 5 by 4. The next one is cosec C. As per the ratio, cosec C is equal to hypotenuse by opposite side. So what's the hypotenuse? It's 5 by the opposite side is 3. So 5 by 3 is the value. The next one is tan C. Tan C is equal to, what is tan? Tan is opposite side by adjacent side. And that is same as, what's the opposite side? 3 by the adjacent side is 4. So 3 by 4 is your value. This is how we can find the trigonometrical ratios with respect to the angle of reference. Whenever the measurement of one particular side is missing, you need to use the Pythagoras theorem. Pythagoras theorem to find the missing side. Consider the next question. Triangle ABC is given. AB is 8 centimeter, BC is 17 centimeter. We need to find cos B, tan C, sin square B plus cos square B, sin B into cos C plus cos B into sin C. These are the values we need to find from the single question itself. So here first we need to find the missing side. So AC, the value of AC, we don't know what is that. So as I have told you, whenever the length of one particular side is missing in a right angle triangle, we can use the Pythagoras theorem. According to the Pythagoras theorem, hypotenuse square is equal to base square plus altitude square. Here the hypotenuse is 17. We can write this as 17 square is equal to the base is AB, that is 8 square plus the altitude square. So when you square it, 17 square is 289 is equal to 64 plus a square. Bring 64 to this side. This will be 289 minus 64 is equal to a square, or this implies a square is equal to 225, and that means a is equal to square root of 225, that is 15. So the length of the altitude we are getting as 15. So the value of AC, the length of AC is 15. So now we have the length of all the three sides. Let's find each trigonometrical ratio separately and solve the given question. First one is cos B. Cos B is adjacent side by hypotenuse. Here the adjacent side is AB. So 8 is the value of that. 8 by 17. That's the value of cos B. The next is tan C. Tan C is opposite side by adjacent side. But here the angle of reference is C. C is the angle of reference. When C is the angle of reference, AB is the opposite side and AC is the adjacent side. So tan C is opposite side by adjacent side. C opposite side is 8. 8 by the adjacent side is 15. That is the value of tan C. Now let's find sin square B plus cos square B. Sin square B plus cos square B is equal to sin B the whole square. Sin square B is same as sin B the whole square plus cos B the whole square. And that's equal to sin B. How to find the trigonometrical ratio sin B? It is opposite side by hypotenuse. So here B is the angle of reference. Therefore sin B will be opposite side 15 by 17. 15 by 17 the whole square plus cos B we have already found here 8 by 17 the whole square, and that is equal to 225 by 289 plus 64 by 289, and that is same as 225 plus 64 divided by 289, and this gives you the value as 289 divided by 289, and that is equal to 1. So we can say that the value of sin square B plus cos square B is equal to 1. The next one is sin B into cos C plus cos B into sin C. Sin B into cos C plus cos B into sin C, and that is equal to sin B. Sin B we have already got the value of sin B as 15 by 17 into cos C. Cos C is C, angle of reference is C. Cos C is adjacent side by hypotenuse, 15 by 17 plus cos B. Cos B is 8 by 17 into Sin C. Sin C is opposite side, 8 by 17. 8 by 17. So when you multiply the same value, you are getting 15 into 15 is 225 divided by 289 plus 64 divided by 289, and that's equal to 225 plus 64, that is 289 by 289. Here the denominators are equal. You can just add the numerators. 225 plus 64 is 289 and it is 289 by 289 and that's equal to 1. So the value of sin B cos C plus cos B sin C is equal to 1. Here always you need to remember one point is that according to the angle of reference, you need to find the opposite side as well as the adjacent side. Whenever B is the angle of reference, correspondingly you will get the value, and when C is the angle of reference, your values will change. Consider another question. Given sin A is equal to 3 by 5, find tan A as well as cos A. Here there is no triangle given. So whenever we solve any such kind of question, the first step is to draw a right angle triangle. Let's draw a triangle. And it is given that sin A is 3 by 5. That means A is an acute angle. So here let's write this A, B and C. This is 90 degree. So we can see that this is the hypotenuse. Side opposite to 90 degree. Since angle A is the angle of reference, this is the opposite side and this is the adjacent side. The side which is adjacent to the angle of reference. Now look at this. Sin A is 3 by 5. What is sin A? Sin A we know as the trigonometrical ratio sin A is equal to opposite side by hypotenuse. And that is equal to 3 by 5. So the value of opposite side is 3 and the hypotenuse is 5. We have two sides. So we need to find the adjacent side. Again, by using Pythagoras Theorem, let's find hypotenuse square is equal to base square plus altitude square. Hypotenuse is 5. 5 square is equal to base is 3. 3 square plus altitude is, we don't know, altitude square. So this is 25 is equal to 9 plus a square, or 25 minus 9 is equal to a square. This implies a square is 60 and that implies a is equal to 4. So the side AB we are getting as 4. This is 4. Now we have all the values. Hypotenuse is 5, adjacent side is 4 and the opposite side is 3. Let's find tan A. Tan A. What is tan A? Tan A is opposite side by adjacent side. The opposite side is 3 by the adjacent side is 4. So the value of tan A is 3 by 4. The next one is cos A. Cos A is adjacent side by hypotenuse. Adjacent side by hypotenuse. The adjacent side is 4 and the hypotenuse is 5. Therefore cos A is 4 by 5. This is what the required value. Now you can solve these questions and find the answer. Given cos A is 5 by 13, find cot A and sin A. That's the first question. In the second one, there's a triangle given ABC and this angle B is 90 degree and angle D is also 90 degree. You need to find cos A, cosec A, tan square A minus sec square A, sin C and sec C. Here you don't have the value of AC, but you know what is the side of the triangle BDC. BD is 4 and BC is 12. So by using Pythagoras theorem, find this missing value. This value, after finding this value, you get the value of the hypotenuse when you are considering triangle ABC. Then find the given trigonometrical ratios. It's given that this angle B is 90 degree. Solve it and let me know the answer. That's all for today. We'll continue with the same chapter in the next class. Thank you.